Welcome to ZoomInData. In this video, we are starting a very important section of Azure Data Factory, which is mapping data flows. This is the foundation video, where we clearly understand what data flows are, why they exist, and how they fit into Azure Data Factory. We will not jump into complex transformations yet. Instead, we will build strong fundamentals so that the next videos become very easy to understand. Before data flows were introduced, Azure Data Factory was mainly used for data movement, not transformation. Copy activity can move data from source to destination, but it cannot clean, join, aggregate, or modify data. In real projects, data is rarely clean. Mapping data flows solve this problem by allowing us to transform data visually inside Azure Data Factory itself, without writing complex code. A mapping data flow is a visual way to design data transformations in Azure Data Factory. Behind the scenes, Microsoft uses Apache Spark, which means data flows are powerful and scalable. Even though Spark is used internally, we do not need to write Spark code. We simply design transformations visually, and Azure handles execution. It is important not to confuse copy activity with data flows. Copy activity is best when you only need to move data quickly. Mapping data flows are used when you need logic, such as filtering rows, joining tables, or cleaning data. In real projects, both are used together inside the same pipeline. You should use mapping data flows whenever your data needs processing before loading. For example, removing duplicates, joining customer and transaction tables, or applying business rules. If SQL logic becomes too complex or unreadable, data flows provide a visual and maintainable alternative. Azure Data Factory provides two types of data flows. Mapping data flows are used for structured, rule-based transformations. Wrangling data flows are more interactive and UI-driven. In enterprise projects, mapping data flows are far more common, which is why this course focuses only on them. At a high level, a data flow always follows the same pattern. Data comes from a source, passes through one or more transformations, and finally goes to a sink. Azure automatically creates Spark clusters during execution and shuts them down afterward, so you don't manage infrastructure. The source is the starting point of any data flow. It defines where your data is coming from, such as Azure SQL database, data lake, or blob storage. You can import schema automatically, which helps in designing transformations easily. Transformations are the heart of data flows. They allow us to change the data step by step. You can apply multiple transformations one after another, and the order in which you apply them directly affects the result. The sink is the final step in a data flow. It defines where the transformed data will be stored. You can control whether data should be inserted, updated, or upserted based on keys. Debug mode is extremely useful during development. It allows us to test transformations with sample data before running full pipelines. This helps catch logic issues early and saves both time and cost. Both SQL and data flows are valid options. Data flows shine when logic becomes complex or needs to be reused visually. SQL is still great for simple transformations. A good data engineer knows when to use which. Because data flows use Spark, they are more expensive than copy activity. That is why efficient design, limited debug usage, and optimized transformations are very important in production systems. Beginners often misuse data flows. If you only need to move data, copy activity is enough. Leaving debug mode on is another common mistake that increases cost unnecessarily. Data flows do not run alone. They are executed inside pipelines, which control scheduling, dependencies, and parameters. This allows complete orchestration of data processing workflows. In real projects, raw data is first ingested, then cleaned using data flows. Business rules are applied, and finally, clean data is loaded into a data warehouse or analytics system. In the next video, we will start working with actual transformations. You will learn how to filter data, select columns, and apply basic logic step by step. The key takeaway from this video is that mapping data flows are essential for real-world data engineering. They allow scalable, visual, and maintainable transformations inside Azure Data Factory. Before moving forward, ask yourself these questions. What problem do data flows solve? When should you avoid data flows? What is the role of Spark? How do data flows differ from copy activity? If you can answer them confidently, you are ready for the next video. Thank you for watching this video on ZoomInData. If you found this helpful, please like, share, and subscribe to the channel. I'll see you in the next video, where we start working with real data flow transformations.